The secret of getting ahead is getting started. Hi students, in this video we'll go through additional problems from types of functions from exercise 1.2. You can refer relations and functions playlist for videos related to this particular chapter. You can also join Telegram group for mathematics to get further updates and notifications on videos. Let's look at third problem. Prove that the greatest integer function from real number to real number given by function, this is a greatest integer function, is neither 1 nor onto, and x denotes the greatest integer less than or equal to x. So what is greatest integer function? So now if I take f of 1, then it will return 1. If I take f of 1, then the greatest integer function will give 1. If I take f of 1.1, then it will be 1. Greatest integer, that means you will have to take only the integer number. So if you have numbers with decimal points, you still have to take the whole number or the integer. So if it is 1.1, then the integer is 1. So you should take integer which is less than or equal to x. Less than. So if this is x, you will say f of x is equal to greatest integer function, right? If you have f of 1.1, then you should take value less than x. Value less than x. Value less than 1.1 is 1. So it should be an integer. It cannot be a decimal. So if I have 1.9, then the integer is 1, right? Lesser than this, right? So if I have 2, it's going to be 2. If I have 2.1, then it's going to be 2. If I have f of 2.9, then it's going to be 2. So basically only take this integer number. You only take this integer number. This is for positive numbers. Now if you take negative numbers, what will happen is you will have to take integer greater than x if it is negative. And if it is positive, you should take number less than x, right? If it is positive. So if you have minus 1.1, then it's going to be greater than this. What is greater than this number? It's 2, minus 2. So you'll take minus 2 here, right? And if it is minus 1.9, then also it will be minus 2, right? Now if I have, say, f of minus 2.5, then what is the greatest integer function? It will be minus 3. So if I have f of minus 3.9, then the greatest integer function would be minus 4. So basically it should be less than. So obviously when it is negative numbers, less than, minus 3 is less than minus 2.5. Minus 4 is less than minus 3.9 in case of negative. So it should be less than or equal to x, right? So if it is positive number, you take only this integer. If it is negative number, you take this integer and add another 1 to it. So you have minus 1.1, so it will become minus 2. Here you have minus 2.5, so take this minus 2, increase 1, so it will become minus 3. Take minus 3, increase 1, it will be minus 4. Now you will have to prove that this kind of a function, greatest integer function, is neither 1 nor onto. If you take x as 1, you get answer as 1. If you take x as 1.1, then also the answer is 1. So if you see here, x is 1, x is 1.1, but both are mapped to 1 here. Here, if you notice, 1 and 1.1 are mapped to 1. 1 and 1.1 are mapped to 1. Here, 1 is also mapped to 1. 1.1 is also mapped to 1. 1.9 is also mapped to 1. So this is many to 1, right? It's many to 1. It's not 1 to 1. So you can tell this function from R to R, that is the greatest integer function from R to R, is not 1 because 1, 1.1, 1.9 have same image. which is 1. Therefore, f is not 1 to 1. This is using example. Next, let's look at onto function. Right? Now in onto function also, the same set, right? You assume that set as 1, 1.1, 1.9, 2, 2.53. Here also similar set. Both are set of real numbers. Right? So it can have positive numbers, it can have negative numbers, it can have whole numbers, it can have decimal numbers, right? It can have decimal, it can have integers, right? Now, here if you notice, you will never get 1.1 and 1.9. These numbers will never be mapped to any number in this set, right? If you take f of 1.1, it is 1. If you take f of 1.2, it is 1. If you take f of 1.3, it is 1, right? So 1.1 and 1.9 or any decimal numbers between 1 and 2, any decimal numbers will not have a pre-image. So 1.1 and 1.9 has no pre-image, therefore f is not onto. Therefore, we have proved that this greatest integer function is neither 1, 1 nor onto. Now let's look at modulus function. Show that the modulus function from real number to real number given by, this is modulus function, mod x, is neither 1, 1 nor onto, where mod x is x if x is positive or 0, and mod x is minus x if x is negative. So here you have two cases. One is when x is positive or 0. The other one is when x is negative. Positive or 0 means x greater than or equal to 0. This is positive or 0, this particular case. Now when it is positive or 0, modulus of x is x. So you'll get x. And modulus of x is minus x. It is minus x when x is negative. What is negative? X is less than 0. Right? X less than 0 is all negative numbers. You'll have to show that this function is neither 1, 1 nor onto. So what is modulus function? Modulus is whether you take positive x or negative x, whether you take minus x or plus x, modulus will always give you plus x only. It will always give you plus x. So if I take modulus of minus 1, it's going to be 1. If I take modulus of plus 1, then it's going to be 1. Modulus of minus 2 is 2. Modulus of 2 is also 2. Now, here itself, you can see that when you take x values as minus 1 and x as 1, you'll get the same image. Same image. So this is many to 1 because two numbers are mapped to same number. Two numbers are mapped to same number. So it's many to 1. So you can say f is not 1, 1 because 1 and minus 1 have same image. Now for onto function we'll check. Now whether you take positive numbers or negative numbers, the image is going to be positive, right? Take plus 2 or minus 2, image is 2, right? Similarly, you can take decimal numbers, whether you take minus 0.1 or plus 0.1, modulus function will give you plus 0.1 only, right? Therefore, these images minus 1, minus 2, the negative numbers don't have any pre-image, right? These negative numbers are not mapped to any element in this set. So, minus 1, minus 2 has no pre-image, therefore f is not onto. So, we have proven that modulus function is neither 1 to 1 nor onto. Now, let's look at the next example. Show that the signum function from real number to real number is given by, this is the signum function, is neither 1, 1 nor onto. We'll have to prove that. So, signum function is nothing but it has all values of x. X greater than 0, x is equal to 0, x less than 0. for all these values of x, positive, negative and 0, you have some values mapped to it. So here, if x is greater than 0, then f of x is 1, right? So if x is greater than 0, that means if x is, say, any number could be 1 greater than 0. So it could be 1, 2 till infinity. Any number you take which is greater than 0, your f of x is going to be 1. Here itself, say for example 1, 1, 1.5, 2, all will be mapped to 1, right? These are all numbers greater than 0 and all of them will be mapped to 1 because f of x is 1 here. Similarly, if you take x less than 0 here, if x is less than 0, that means you take negative numbers. Minus 1, minus 1.5, 2, minus 2. Now all these numbers will give you f of x as minus 1, right? This is minus 1. So all the numbers, all the negative numbers will give you minus 1 as f of x. So all these negative numbers are mapped to minus 1. So this itself tells it's many to 1, right? Many elements in this set are mapped to one element in this set. So it's many to 1. So you can say here f of minus 1 is equal to f of minus 1.5 is equal to f of minus 2 is equal to minus 1. So all these x values, minus 1, minus 1.5, minus 2 have the same image which is minus 1, right? Therefore, function is not 1, 1. Also you can say f of 1 or f of 2 or f of 3, all these values of x which is 1, 2, 3 give you the same image which is 1. Therefore, it's not 1 to 1. Now we'll check if it is onto. We know that this is a set of real numbers. So real numbers will have all elements, positive, negative, decimal numbers, everything. Now if you see only 3 elements, 1, 0, minus 1. This is minus 1. Minus 1, 0, 1. Only these 3 elements have pre-images. Only these 3 elements are mapped to some element in this particular set. But plus 2, minus 2, plus 3, minus 3, all these numbers, all these other numbers have no pre-image. So you can write 2 minus 2 have no pre-images, therefore f is not onto. So now we have proven that function is neither 1, 1 nor onto. Now let's look at this particular example. We have set A which is 1, 2, 3. We have set B which is 4, 5, 6, 7. And the function is having these list of ordered pairs 1, 4, 2, 5, 3, 6. Show that function is 1 to 1. So you have a function from set A to set B and you have to show that function is 1 to 1. Now you should write it in this particular notation. You say function, you write set A here, it has 1, 2, 3 elements. Then you have set B 4, 5, 6, 7, right? And then there is a function from this A to B. Now 1 is mapped to 4. So 1 is mapped to 4. Next 2 is mapped to 5. So 2 is mapped to 5. Next 3 is mapped to 6. So 3 is mapped to 6. Is it 1, 1? Because it is 1, 1 because every element in this particular set is having a different image. Different image. 1 is mapped to 4. 2 is mapped to 5. 3 is mapped to 6. So every element here is mapped to a different element in this set. Therefore, this is 1 to 1. Right? Now, is it onto? Right? It's not given in the question, but is it onto? It is not onto. Why? Because this element 7 has no pre-image. Right? This element 7 is not mapped anywhere. It's not mapped. Right? Therefore, this is not onto. Now, let's go to this example. In each of the following cases, state whether the function is 1, 1, onto or bijective. 1, 1, onto, bijective. Bijective is both 1, 1 and onto. This is bijective. And justify your answer. Basically, you have to explain as to why it is 1, 1, onto or bijective. Now, we'll take the first one. Function is from real number to real number and the function is given as 3 minus 4x. So, we'll use this method f of x1 is equal to f of x2. Right, whenever you have such functions, right, it's better to use this particular method. Instead of x, I'll put x1. And here it will be 3 minus, instead of x, I'll put x2. 3 minus 4x2. 3 and 3 will get cancelled, right? So I'll be left with minus 4x1 is equal to minus 4x2. Now obviously minus 4 and minus 4 will get cancelled. This infers that x1 is equal to x2. Therefore, f from R to R is 1 to 1. Now let's check if this function is onto, right? So we'll start writing. Let y is equal to f of x. What is f of x? 3 minus 4x. So I need to get just the value of x. So what I'll do is, I'll shift 3 this side. So I'll get y minus 3 is equal to minus 4x. Or I can say y minus 3 by minus 4 is equal to x. I'm shifting this here, right? I can write it like this, which means x is equal to minus y minus 3 by 4. Now I have to apply function on this, right? I'll say f of x. X is this much. Now I'll write f of x. What is f of x? 3 minus 4x. Now instead of this x, I'll put this entire value instead of x, right? Instead of x, I'll put this entire value. So it will be, so minus into y is minus y, minus into minus is plus 3 by 4, right? Now what will happen? This 4 and this 4 will get cancelled, right? So I'll be left with 3 minus of minus is plus, so plus y, minus into plus 3 is minus 3. Now again, plus 3 and minus 3 will get cancelled. I'll be left with y. So f of x is equal to y. Now whenever we get f of x is equal to y, that means the function is onto. So this implies that function is onto. Function is 1, 1. Function is onto. So what does this mean? It means that function is bijective. Because it is both 1, 1 and onto, function is bijective. Now let's look at the second part of the question. Right here, the function is given as 1 plus x square. Same method we'll have to use. We'll have to show that it is 1 to 1, you will have to show that x1 is equal to x2. And here, to show that it is onto, you will have to use this method where y is f of x, y will be this function 1 plus x square, right? We can try 1 to 1. So f of x is 1 plus x square. So f of x1 is equal to f of x2. So instead of x, I'll put x1 square. Here, instead of x, I'll put x2 square. 1 and 1 will get cancelled. So I'll get x1 square is equal to x2 square. This implies that plus or minus x1 is equal to plus or minus x2 because there is square. Now, this is a function of real numbers. This is a function of real numbers. If I take minus x1, it can be equal to x2. Or if I take plus x1, it can be equal to x2. Now, if you notice, here minus x1 or plus x1 could have same images. There is a possibility that both positive x1 and negative x1 will have the same image, x2. Therefore, it's not 1 to 1, not 1 to 1. Because minus x1 and plus x1 has same image. Now we'll check if it is onto. What is f of x? It is 1 plus x square. So I'll say y is equal to f of x, which is nothing but 1 plus x square. So now I need to find the value of x. So I'll be y minus 1 is equal to x square. Therefore, x would be root of y minus 1. Y belongs to real number, right? Y belongs to a real number. So I can have negative numbers, right? So if y becomes a negative number here, right? Suppose if I take y as minus 2, then this is going to become root of minus 3. right? Minus 2 minus 1 is going to be root of minus 3. The square root of minus 3 does not belong to real numbers. Therefore, this function is not onto. So now this function 1 plus x square is neither 1 to 1 nor onto. It's neither 1 to 1 nor onto. With this, we've come to the end of this particular topic. We'll solve some more problems in the next video. If you have found this video useful, do press a like and share it. Thank you.